right. Well, thanks very much, Laura. It's great to be back with the Sustainable Buildings Manitoba group. I should be sharing my screen now, so let me know if you do not see it.
Good to go.
Great. So I think we did a presentation on the PEER project a couple of years ago, about 2 years ago. So we won't go through, we won't rehash any of that. The focus of today's presentation will be really on the exciting Ottawa Community Housing pilot project and the facility that they've built to prefabricate the panels that will be used in that demo project. But we have just a couple of slides and background here, so let me go ahead and get started. So PEER is a R&D project, and it's a 5-year R&D project. And really what we're trying to, I guess, answer with this project is, recognizing that traditional deep energy retrofits are slow, they can be inconsistent, often they're very disruptive, especially if they're sort of a gut retrofit, and frankly, they've been rare. And we know we need to dramatically increase the number of deep energy retrofits that we're doing to meet various climate change targets, both federally and at the municipal level. So we've seen opportunities to use a more systematic and industrialized way to do deep energy retrofits to kind of scale up the overall approach, but also doing as much of the work as possible from the exterior to really minimize the amount of disruption to occupants of a building. So the goal of our project is to develop prefabricated building envelope solutions to achieve a net zero ready heating demand. So that is basically bringing the heating loads down low enough that if the building was suitable for renewables, you could get the building to net zero. And the reason we're focused on heating demand is because about 2/3 of our energy use in our existing homes and buildings comes from space heating. So our main question is, can factory-built super-insulated airtight panels be installed directly over existing buildings? And would that be a better way to do deep energy retrofit? And we're focused in 3 main research areas. The first is what we call building capture. That's looking at recent developments in technologies like laser scanning and photogrammetry to quickly and accurately measure a building, get all the dimensional data that we need to custom build a set of panels that will fit when they arrive on site. We are developing panel prototypes. We have 2 to date. OCH project is using one of those, so you'll hear more about it then. And also developing guidance in terms of their design, their fabrication, and their installation. And then we're also looking at the building science implications of doing this. At the end of the day, we want to have more energy efficient buildings, but we also want to make sure that these buildings are comfortable, that they are durable and resilient, and that they are healthy for the occupants who have to live in them. When we spoke last, we talked a little bit about Energy Sprong, and so I'm sure most people are familiar with this, but for those who aren't, this is an initiative that originated in the Netherlands and is now spread across Europe and is even making inroads in North America. And Energy Sprong's really kind of revolutionized the way we think about deep energy retrofit, because they're doing these net zero retrofits in a matter of days using prefabricated building envelope and mechanical systems, and really standardizing the approach. So we're with our project, we're really just trying to adapt those types of solutions for a Canadian context, for our climate zones, for our built form and building traditions, and for our construction industry. There are some important ways that the Canadian context, I think, varies from that of the Netherlands. Not only is it colder, but we have multiple different climate zones. So we have a lot more variability, and so the solutions will have to vary regionally. We have a much lower population density, and it's obviously spread out. our population. We have a wood frame building tradition for our low-rise residential projects or buildings. Most of our homes in Canada are almost all wood frame versus a masonry tradition there. We have very different energy costs, and that affects the business case of doing this. We also don't have as well a developed industry in terms of its capabilities of offsite fabrication. And we have a more heterogeneous housing stock. Our housing stock varies a lot by region and by vintage. So all that said, you know, the solutions do have to, I think, kind of conform to some of these different parameters. We set out at the beginning of our project, imagining what this would look like to be successful in Canada. And it wasn't just us making this up. We spoke a lot to industry, to the types of folks we could imagine doing these types of projects. And on the one hand, there's this sort of revolutionary approach, which they've accomplished in Europe, where one of the key things about Energy Sprong is they started by creating a very large market that didn't exist before. So they went and identified social housing or affordable housing as the catalyst market, and worked with housing providers to aggregate a large demand. So they got 100,000 units lined up and built the pipeline, then went to industry and attracted very large industry players, and asked those players to invest in a solution and the facilities to fabricate and manufacture the components. They're tackling everything at once, going all the way to zero, and with the goal of consolidating the supply chain and ultimately in automating parts of this process to drive down the cost. In Canada, so far, we don't have that market development activity. I think that needs to be regional because we're spread out. But we do know that there's already a very reasonable market size in just about every urban center. I think we're going to need to attract a wider variety of industry players. Large players would be fantastic, but some smaller and medium-sized companies can get involved in this space because we're so spread out. We can start now with what we know is technically and economically feasible, and we think that the building envelope upgrades are the logical place to start. And then we can assume that costs will go down as the market is proven and competition takes hold. So this next slide is kind of it's useful to imagine where we are and where the ultimate kind of prefabricated factory finished panelized solution might be. In the Netherlands, finished wall panels are rolling off assembly lines onto trucks and installed on site. Currently in Canada, retrofits are still stick built on site. So you can kind of imagine this space between as a continuum, and there's some interesting spots, I think, to pause and consider along that continuum. So, you know, with a fully stick-built, site-built type of solution, we're here at the far end of the spectrum. Then as we move along here, this first stage is a point where a manufacturer produces a base panel, and that could be finished on site. We've talked a lot to manufacturers, and one of the things that's become quite clear is that a typical manufacturer mindset, most manufacturers are not interested in doing things like installing windows in panels or adding control layers or adding strapping and siding, because that has to vary from project to project. It's difficult for them to do that on an assembly line. But they can produce a standardized base panel that gets shipped to site and then gets finished by a contractor on site. So that's sort of stage one. Stage two is taking that base panel and taking it to a second shop and fabricating it. So adding those different elements, the things like windows and control layers and cladding. And then finally, a fully factory finished panel, which some manufacturers may actually be able to produce, and then on with varying degrees of sophistication and automation. This contractor who does the site work and manages the contract could also be the fabricator. And in the case of the Ottawa Community Housing pilot project you're going to hear about, that's basically the role that OCH has filled themselves. They're working as their own general contractor, and they're also building and fabricating the panels themselves. And as we move along this continuum, we have increasing degrees of industrialization, and that promises to decrease the cost of doing this, but also to decrease the occupant disruption, because the more work that can be done off-site, the less intrusive the retrofit. But I think for industry to see that there's a real market for this, they need to know that there's demand, and they need to also understand the business case and make sure that there's money to be made doing this. So we're at a stage with the project now where we're moving on to pilots to answer some of those questions. You know, pilots I think are really necessary for demonstrating that this is technically feasible here, but also understanding what the real costs are and what the business case for doing this type of work is. So we completed a retrofit. I spoke about this, I think last time I spoke to this group. We did a small proof of concept pilot on our campus in Ottawa in 2017. We tested 2 different wall panels side by side. We continue to monitor those. Those are both performing really well. In Edmonton, the Butterwick Construction Group is undertaking a large demonstration project with the Sundance Housing Co-op, where they're retrofitting about 60 units of co-op townhomes and row homes all the way to net zero ready. That construction is underway. And then of course with Ottawa Community Housing, we're doing this pilot in Ottawa where we're taking 4 row homes all the way to net zero. So I'm going to hand it over now to Dan DeCare, who can talk from OCH's perspective.
Thanks so much, Mark. So hi, everyone. Just maybe a little bit of background on Ottawa Community Housing. So Ottawa Community Housing is the largest social housing provider in Ottawa, second largest in Ontario. We've got about 15,000 units throughout Ottawa. And that's anything from, you know, we've got about 100 different high-rise or elevated apartment buildings, 60 townhouse communities, anything from, we've even got single-family detached to 200-unit high-rises, a very, very big mix of different types of construction. But one of the things that they have in common is that they are, 2/3 of our portfolio is over 50 years old. So we are getting to kind of a life cycle tipping point for a lot of these assets that were built in the 1960s, 1970s. Another thing about Ottawa, and like similar to across Canada, in all honesty, we've got a 10,000 person waiting list. There's a little bit of a housing crisis that's taking place in terms of affordable housing throughout Canada, in fact. And that's kind of shaped the way that we're behaving. So we're definitely investing in new development and redevelopment of some of our sites, but obviously adding new, and so adding and densifying is part of the plan. But at the same time, you can't be giving up assets that exist right now, or else you're not making up any ground. So giving new life to assets that are at a life cycle tipping point, like some of these 50, 60-year-old townhomes, is absolutely crucial. And that's why we're looking at long-term strategy. And when we found out about the PEER project, it was such a nice fit with what we're trying to achieve. If we look at the next slide. PEER answers a lot of questions very, very elegantly. So if we are trying to keep these assets around for the next 30, 40, 50 years, we know we're going to be incurring a great deal of maintenance. We're going to keep these things up at least at a baseline. So there's a certain amount of money that's going to be spent, as well as a certain amount of energy, given that they have typically low energy performance. So the net present value today of all of those costs that will be incurring over the next 30 years, we could basically be putting them all up front. Yep. Yes.
Sorry, Dan, you're just breaking up a little bit in sound. So if you could just slow down a little bit, I think it might help with the breakups.
Perfect.
Okay, thank you.
I do have a tendency to speak very fast, so please feel free to slow me down. But yes, the net present value of all of our future maintenance work, as well as the energy savings, the idea is we can spend that today and give ourselves, in order to finance that next 50 years of life cycle on these buildings. The no need to displace tenants is very important. If we had to displace tenants, then we are not actually making up stock. If we have to put them somewhere else, we're not gaining units, which means we wouldn't be catching up on our goals. So keeping the tenants in place is very important. We have that highly repeatable template. A lot of our communities, our groups have one template, and we probably got 100 to maybe even 200 units that follow a similar template, which means we've got that repeatable approach that can take place. And overall, the most important thing is the elimination of GHGs from this huge, very decentralized sector. Ottawa recently adopted its climate change master plan, which targets 2040 as zero emissions for the city's operation, and then 2040 for zero city of Ottawa operations, and then 2050 for Ottawa as a whole, so the entire private sector as zero emissions. So we're using kind of those targets, and we're looking for these types of solutions on how we're actually going to get there. And PEER seems to be a very elegant way of achieving it for low-rise fabrication. Next slide. So let's have a look at the building that we're actually going to be building on. We're actually starting next week to do the extension on the back of the house to do with the electrical upgrade. So this is 197 to 203 Prescient. It's a 2-story, 4-unit block of townhomes. And we see, very typical energy consumption. There's significant air leakage. There's, some foundation issues, a little bit of leaking, deterioration or falling brick, some old windows that have never been replaced in the life cycle of this building. All the types of things that you would imagine to find in a 1950s, 1960s, 1970s build. But once again, the important thing about that one is that we have 400 units just like that one lined up down the street. So figuring out one template and then repeating it over and over again is extremely appealing. So what does that template look like? Well, here we have kind of the base case, what the building is right now in terms of insulation. And then to the right, we've got that net zero retrofit. So what is it going to take these four units and essentially bring them down to net zero energy, all generated on site, and net zero GHG emissions? We're talking about, obviously, significantly increasing the insulation value, both in the attic and in the walls above and below grade. We're not going under the foundation, though. And then increasing the air tightness significantly by at least 75%, and if not even maybe a little bit better. Once we have that very tight building envelope, obviously reduce that 2/3 of the energy that Mark was talking about before. We've significantly reduced that. So our space heating and cooling in our domestic hot water can now be taken care of by electrification. So a new mechanical system that's going to be heat pumps, and then we're going to get rid of the natural gas that is currently heating these pieces of equipment, and adding some active ventilation through an ERV that's going to be able to recover the energy that we put into the system. And finally, now we've got really efficient building, really efficient mechanical system. We can talk about renewables and saying, well, now that we've reduced the energy load so much, now it makes sense, and the available space on the roof can now provide ample amounts of energy, can basically generate as much as what the building will be consuming throughout the year. So around 34 kilowatts of DC is what we're planning on putting on the south-facing roof of this building. And just in terms of what that's going to look like graphically, so our space heat is getting reduced by over 90%, the domestic hot water by over 75%. The lights and appliances are pretty much staying around the same because we're not trying to change too much inside the building. We're really focused on the outside. The fan and ventilation, I mean, there was a furnace before, there's still going to be a fan circulating air again. The space cooling, however, is something that is not present in our building right now. And that is a change, so it's an increase. But since we're relying on those internal heat gains, essentially we're kind of retrofitting this to pass as a standard. Since we rely on those internal heat gains to heat the unit during the winter, well, we're going to need to take care of them during the summer as well, or else we're going to overheat. And then obviously that last generation, which is not present at all right now, is how we're going to make up any sort of consumption. We've got this generation system that completely covers the entire consumption on an annual basis. So an overall energy balance that we see at the end, that we've basically, we're covering 100% our generation. In fact, we even have a little bit of a buffer in the event, you know, there's going to be shade, there's going to be some soiling of the panels and things like that. So that's how we're going to hit net zero on this fantastic building. So now let's talk about the actual implementation. So what you're looking at right now, although it looks like a picture, it is actually a laser scan of the buildings. And so those are tiny, 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 tiny little pictures. And that's why there's also streaks where the stacks kind of block the laser. But this is necessary in order to get an extremely precise and rapidly get a very precise model of the building, so that when we take it back to the shop, we know exactly where every window and every door is going to be. And from that, we generate these very precise measurements that you see right now, so that we do know where all the doors are, where all the windows are, as we're building our panels in the shop. So this is our existing building before here on the left. So what's going to be taking place is, well, we're going to need to be taking off the eaves, because we're essentially going to be wrapping this existing building with an entire new skin. Basically, it's going to be looking something like this. So we're going to take it step by step. The first part we're going to start is down in below grade. So below grade, we're going to be doing some excavation, whether with some hydrovac or perhaps with just a mini excavator. We're going below grade, we're going all the way down to the footings. And at that footing, it gives us an opportunity to put in a weeping pile and address any sort of existing water infiltration issue and give it a new life, because we don't want to go back down there again for the next 50 years. We're going to be cleaning off that the foundation and putting a membrane across. It's going to be air and water membrane to get completely impermeable. And on top of that, we're going to be putting insulation, so that we really cover that foundation and give the foundation that extra R value that it's looking for. And as we get to the top and we get to above grade, there's going to be a bracket. It's going to support brackets that are going to support a grade beam that's going all the way around the entire base in order to support the above grade panels, which are right there. So as we get to the above grade panel, we've got, oh yes, am I going too fast again?
Yeah, and I feel like it keeps getting a little bit worse. So do you think we could switch to doing the video? I just sent you the information on how to call in with the audio. And so if we just want to go to the video, we could get you called in and then hopefully fix up that sound.
Okay. Sorry about that.
That's okay. So we're just going to go, do you want to just, either one of you want to introduce the video?
So you just want to go to the like skip the rest of the presentation and go to the video?
We'll go to the video and then we'll come back and finish the presentation once you can call in, so that we can not have your audio break up.
Oh, okay. Okay, sounds good. So how about this? Well, what you're about to see is our prefabrication facility. And you know what? It kind of introduces itself. Okay, give me 1 second and I'll call in. Damn it.
Mark, can you just stop sharing your screen there quickly? I don't know, it's not letting me share over you. Sorry, folks, for all these technical challenges. Here we go, there we are. All right. So, share is this. Share. All right.
All right, welcome everybody. I'm Dan Zikag and I'm live here on location at the OCH Prefabricated Exterior Energy Retrofit Construction Facility with the all-star team that is going to be making Canadian history in prefabrication and deep energy retrofit. So we've got Sandy Farquhar, we've got Keith Gagne, and Evan Gillis. So guys, tell me about where we are right now in this fantastic shop that you guys have set up.
So we're at the rented space, and what we've done is we've fabricated a shop out of sea containers. You can see we had some sea containers on both sides, poured a concrete slab, and we've added some trusses on top and put some inexpensive roofing material and created this space so that we can work indoors, and we can also hoist our panels, which are significantly large and heavy. And you can see the hoisting system that we put in place, and that's what we use to move the panels around. So the panels get built on a table, which is full of parts for the windows and the window box. And we fabricate the panel on here and we move it to the left-hand side of the shop.
Now tell me, especially about the table, the middle comes out, right?
So the middle comes out of the table so that we can actually do cutouts of windows and doors. So you can pull out the middle table, it creates another table, and you have all that space to work in. So you don't have to move the panels to cut the windows through. We use a beam cutter to cut the cis panels, which are about 8 inches thick.
Yeah, actually, yeah. Tell me about some of the tools that we're using in here, and because I know there's like a chainsaw thing that I saw in one of the.
That's the beam cutter.
Beam cutter. Okay. What does that look like?
Essentially, just a chainsaw with guard, so you can cut square. Safe, clean cut.
There we go.
Now it's onto the skill saw. This is the actual beam cutter itself, and just standard skill saw. Worm drive for this one.
Cool. And then, like, I see.
Yeah, it's just our standard chop saw, table saw, various hand tools, you know, whatever we need, clamps, etc.
Everything mounted on wheels so that we can move from one end to the other and just make things a lot more efficient.
Excellent. All right, so how about some of the materials? What are we putting together, basically, and what is that finished product? What does it start as, and what's our finished product?
This is the cutout section of one. Each end is like this, where it's notched out. And then if you look from the end here, we fit a beam with LSLs and plywood inside, and this is going to sit on our beam. So this is pretty much skinning the whole building just to keep it insulated and better our value. And we covered up with the membrane.
And the membrane is Stratus SA, so these are 4.5 foot sheets, 4.5 foot rolls that will get laminated to the surface of the panels, and that will create the air barrier that is required. And that will be continuous from the foundation all the way up to the roof, and create a proper seal.
And the windows and the doors are also getting cut out and installed in here, right?
Correct. So the next step will be to essentially lift the panels back up and throw the window box and the capping and everything that's required around the windows, and the windows will be installed within the cavity, so easy removal. If ever we need to replace a window, it cuts out from the outside and you pull the window out. The siding will all be placed on these walls prior to shipping. And that makes a complete assembly, and then there's tie-in trim that will tie the panels together.
Excellent. All right, and now let's talk about how we're actually moving. These things are giant. How are we actually moving these things around within the shop, but then also outside, on site, and then onto our actual construction site?
So we use a series of straps, you know, that are good for like 5,000 pounds. The panels weigh about 1,800 to 2,200 pounds, depending on how many window and door cutout are made out of that. And we have the hoists that just roll on a track. And then we hoist the panels up flat. And also turn them vertical, so then when we start putting the siding on, the panels get to vertical state, and then we pull them out onto a rack system.
All right. Wow.
We got some racks fabricated. We have 3 racks. So essentially, one rack goes on a transport truck, the other rack stays here, and one rack gets moved to the field, so that we load up the racks here, ship them out to the site, unload onto another rack, and then we continue that cycle where all the panels are considered racks. So we have the potential to carry 6 complete wall sections. per load. So we have something like 30 some wall sections of different lengths. These are the shorter end wall panels. There's 2 per end wall. And then we have a 23-foot middle wall section for each unit.
All right, and tell me about some of the equipment to move them around.
Yeah, so some of the equipment are, so just locally in the shop and around here, we're using the small Terex machine for a couple of panels. We have some extended forks on them. And then we use the Vici machine to essentially lift the panels vertical and move them out onto the racks. At some point, this machine will go to site and will be used to lift the panels onto their final resting position. Perfect. So there's a bunch of material in the back of the machine there that's slated for the roof structure. LVLs, LSLs, 2x6s, plywood, there's all kinds of material there that are solely intended for the roof section.
And we'll be able to reuse these same types of materials and same types of racks.
The racks will be used for bringing over the actual roof members will all be prefabricated as well and moved to site using either using the flatbed or using some of these racks. So the intended purpose for the racks at a future point in time is if we start making some prefabricated wall systems or floor systems, these will be repurposed for that, for those events.
Fantastic. Well, there we go. And that's how OCH is doing it.
All right, guys, let's see. It's that, oh, you're still muted there, Dan. Do I have to, oh, because you called in.
I can't unmute myself here again.
Well,
Yeah,
maybe,
we can hear you.
yeah, that's way better than it was before.
Okay, well,
Just
let's give it
needed a little bit of
shot. Is it good for now?
Sounds much better than it did. Sorry, folks, about these technical difficulties. Like, praise the internet for bringing us together, but curse it for when it doesn't go perfectly.
Sounds good.
All right, well, I'll let you guys pick up where you left off.
Sure, I'll just reshare my screen. And if there's any more audio problems, Dan or Laura, just let us know and I can hop in if you can hear me okay.
Sounds good. All right. So now, yeah, so we're looking at the above grade panels right now. So those are the 8 by 4 or 8 by 4 by 9 panels that we're all stitching together that are all basically SIPS panels. Through those, we cut out the window bucks and the doors. On top of that, we're going to be putting on our the membrane. So the vertical membrane. Wait, wow, that's different. Okay, perfect. So we're putting on the membrane on top, and so that's how we're sealing the entire thing. And then on top of that, you're going to be putting your strapping, and then eventually your siding. And so coming finished to the site, and then we've got all of those all the way around on the first floor, and then we move to kind of the second floor where we'll have, once again, kind of those box beams as support to make sure that everything lines up very well. But then we've got that membrane that we're able to take from basically the foundation through to the first floor and then into the second floor. And the panels on the second floor are essentially the same as what they were on the ground floor. And then that brings us to our roof, where you can see kind of in the bottom left corner, that blue membrane kind of comes across the panel from the side and then onto over the existing roof. So we are planning on leaving the existing roof kind of as a unvented concealed space, putting 18 inches of insulation on top of the existing roof. So we're now creating a new vented attic 100% on top We're going to be supporting that new roof on top of existing demising walls, and that gives us the structure in order to be able to put on our 35 kilowatts of solar panels on the southern slope. And obviously we're also going to be venting certain things through the attic, and there's going to be a crawl space, kind of a little bit of a catwalk across with doors between the actual units, but it will allow us access through that space if necessary ever in the future. And then obviously what's not shown on here is the mechanical system that's going to be going in the basement. So now, as mentioned, since we've got this new building, we obviously need to get rid of the natural gas combustion domestic hot water tank, as well as furnace in the basement, replacing those with heat pumps that are going to be serviced through we're kind of condemning one of the basement windows as a place to run all the services into the building. So now this would have been where we switched to the fabrication, but we've already done the video, and I know some parts of the audio weren't amazing, but the biggest kind of the story here is that what you were looking at is, some high quality, like Mark kind of alluded to it, OCH is kind of, we're filling in this gap where right now there's nobody that's really acting as. We're very lucky at OCH to have the talent that we do. So Keith's experience and Evan and Sandy's experience as carpenters and as contractors is actually absolutely crucial to translating this theoretical exercise where this started into something that's actually practical and that is actually going to be useful for OCH as a renewal strategy. And the second kind of lesson here is the shop. I love it. It's fantastic, but maybe it's not the most fancy thing that you've ever seen. But the good news about that is I'm sure everybody seeing this could say, hey, I feel like I could build this, right? It doesn't seem out of reach. There's some great thinking that went into this, but it's nothing too complex, and it would be highly replicable throughout Canada if some contractors wanted to put their hands to it and saw a market for it. What?
Great. I was just going to jump in to give a little update of where we're going with the Peer project. So there's the case study you just heard about today. We want to write up and obviously share all the lessons learned through the project that Dan's undertaking with his colleagues at OCH. Ultimately, we're going to be developing a kind of a design guide to walk through the process of doing this step by step. And we're hoping to have that ready for publication next year. So I think that's it, right, from our end, Dan?
Yeah, absolutely. And
so we can open it up.
I'm sure there's lots of questions. So Laura, if you want to play moderator.
Totally. If we just want to stop sharing your screen there, Mark, and then if everybody wants to turn their screens on, let's have a nice little discussion. If you'd like to, that'd be great. Just to make it feel like it's more people here than just talking heads. It's okay if you don't want to also. And it's always nice when we hear from the people themselves about their questions. So please do speak up if you have a question. If you're not comfortable, again, you can just toss it into the chat. If you just want to put a little star in the chat, I can call on you, and that will help make sure that not everybody talks at once and we don't have that you go dance that is a Zoom thing. All right, Mike, do you want to start off there?
Yes, I'm wondering if you've got if you have a thing, how do you choose a substitute energy source for temperature or regulation? Is it generally the prevailing low or no carbon option, or do you try to partner or with forging a new trail, if you will?
Yeah. Well, I mean, from our point of view, we're looking at this from a net zero energy and net zero GHG. So that kind of means we need to generate everything on site, and we've got a good southern facing roof. So solar made the most sense in that, and in all honesty, in a lot of our other situations, in pretty much all of Ottawa, solar will probably be the prevailing extra source of renewables on site and GHG free. And so electrification will likely be part of that, of the retrofit. And also the grid in Ontario is fairly clean. I mean, it's got a lot of nuclear, depending on how you feel about that, but it's got pretty low GHG emissions. So overall, we are kind of, when I look 30 years ahead, we're probably looking at a pretty high level of electrification across our portfolio and across in Ontario at least. And that means heat pumps, and that's how we're going to move away from that will be the low carbon fuel that'll be available to us. At least that's kind of how it looks now.
Okay, all right, so we've got some questions in the chat about your funding. So are you
Yes.
utilizing government program funding, or are these working with private investments? What's that like?
Yeah, so the funding, so we got, me and Mark put together an application to a different part of NRCan for the funding. And so through the Green Infrastructure Phase 2 funding, they're providing 50% of the project cost. And then I had to go to my board and ask my CFO and say, I think this is a great investment for the future. I think this is granted, it is kind of a big price tag for a social housing provider to try and make that leap of faith instead of waiting for somebody else to provide us with a solution. But we felt that it was necessary for us. We were willing to put in that kind of an investment. So 50% of the project cost to determine the solution and also make it something that we know that will be useful to us. So that team that you saw in the video, they are very much dedicated to making sure that the solutions that are being developed are right for social housing providers. So the answer is it's half government, but it's half coming from us. And we've got a green fund, kind of an endowment fund where we've been putting aside incentive money for several years. And that's money is being used to fund these types of projects that are kind of leading us into the next generation of efficient buildings.
Great. Okay, with blue skin and an existing wall with a vapor barrier, how do you reconcile multiple vapor barriers issues?
Mm-hmm. I would actually toss that one over to Mr. Mark.
Sure, yeah. So the membrane that Dan described is actually a vapor permeable air and weather resistive barrier. So it is designed to allow the panels to dry outwards. Now these are expanded polystyrene based panels, and we're using 8 inches of EPS. So there's not a lot of drying potential across that. We skipped over it a little bit, but we're actually, one of the questions we're really interested in is how can we enhance the drying potential of this assembly? So there's actually a material interface between the existing building and the panel. And we're actually going to try to encourage some drying potential up and out the building to dry to the soffit. That's something that is a little bit more on the experimental end of this project, but we have modeled those effects, and we're going to be confirming those with some site measurements and monitoring that we're doing on the project. Drying, just to comment on that, drying potential is really important, especially when we're talking about retrofits, where sometimes we won't know what the continuity of different control layers might be in an existing assembly without doing a lot of demolition. So trying to increase the drying potential is, I think, a really, really smart move.
And just, we are also, the sensors that we're going to be putting inside the panels are going to be making sure that we're not creating any issues, right? Like this is very much a test building. We are making sure that we've got something along each layer so that if there is a problem that we had not anticipated that doesn't go with the model, we will be able to know about it and address it.
Great. All right, Donald, you had a question.
Yeah, I had, I guess, two. How does the foam, the EPS, affect the building carbon balance? And just a quick question about the HRV or ERV selection. We do a lot of cellulose.
Do you want to talk about? You've done
I
that
can field
calculation?
the first part of that. Why don't I do that, Dan, and you maybe can speak to the HRV if you want. So it's a great question, and more we're looking at the embodied carbon, and we did an initial assessment based on the data that we could find for the different materials that went into this project. And we actually looked at two different panel types, one being the EPS-based SIP panel, and another being a wood frame panel that's insulated with cellulose. And certainly the wood frame panel had a lower embodied emissions, but the opportunity in retrofit is on the operational side is huge. It's immense. So I can't remember the overall embodied carbon, but I can dig that up for you and share that. In fact, I think the slide deck that Laura distributed with the invitation to this had some slides about that. But what we did find was that the payback, essentially, the carbon payback was less than 2 years for both panel types. The wood frame was about 1.5 years with the siding that was selected for the project. And the SIP-based panel was about 2 years. So in the grand scheme, anything we can do on retrofit to reduce operational emissions is huge. And for this first generation of panels, we really kind of took we wanted to take, I guess, we made a concerted effort to work with the types of panels that already exist in the market. Our hope with the next phase of this project is to develop a second generation of panel designs that that uses some more innovative insulation materials, but also really addresses the embodied carbon.
And on the so on the heat pump side, so we've got both a domestic hot water heat pump, which is a ream heat pump. And then on the HRV side, it's going to be a Detson system. And all of those, like I said, we kind of got two windows in the back of the unit, and the back of the basement of the unit, and we're kind of condemning one window per unit. That basement is basically all storage space to run the services so that we can get our exchange with the environment. So,
All right, so question from the audience. Have you looked into how the panels are manufactured and installed in Holland? Are those made in small scale workshops like this one, or they tend to be larger facilities?
Oh yeah, they've got videos of their setup. They are they come out of some very, very large, very precise factory lines. They would put our little shop to shame. And I don't know if you've got more comments, Mark.
Yeah, I from what we've seen and what we understand, there are about 5 contractors who are doing this work in the Netherlands, and they're very large commercial general contractors. And it's interesting. Some of them are manufacturing or fabricating their own panels. Some are subcontracting that out. But they have invested in dedicated facilities to build these sorts of things, and like you mentioned, Dan, they're very sophisticated operations, and some of them are even using robotics to and have completely mechanized and automated assembly lines where they're installing windows and everything and flashing them into panels. And that, I think in order to attract that kind of investment, that was sort of the genius of this approach to build a market, right? And without that activity, industry is going to be, I think, very reluctant to invest in that kind of facility. What we're trying to do, I think, through this project, it would be amazing if we ultimately ended up there. And I think, frankly, that's what we need to do in North America. But there's an opportunity to start doing this now with the types of panel shops and panel fabrication facilities we have in the country. So we're trying to kind of take a 2-step approach, I think, where we develop the knowledge tools to help enable the construction industry to start doing this type of thing now, with an eye on the future and what a more sophisticated type of operation could look like once it scales up.
And maybe just a quick note on the market, right? So, I mean, Ottawa Community Housing has 6,000 units of townhomes on its own. I know that all of my counterparts in Ontario and all of the other social housing providers, they're very curious about our solution because they have the exact same vintage with very similar templates, and they would be more than happy to throw theirs into the mix as well in terms of making that market, right? So just in Ontario, we could be already talking about 50,000 units worth of business right here. And then we across, like you bring that to the rest of Canada, and hopefully very quickly we can see that same market.
All right, just a quick question about windows. What is involved in tying in new panels into existing windows?
So the windows are going to actually be inside the new panel, and so very separate from the existing windows. Imagine that essentially you're putting a window in front of a window, and then you're removing that old window and kind of just finishing the sill all the way back to the new window with a nice piece of plywood and painting around it. And then you're really making your new envelope, that continuous envelope ties into the existing, the window in the panel, and that becomes your overall new window barrier, barrier.
Okay, how about the cost per unit right now? How much is it, and how much improvement do you expect throughout the life of the project?
Absolutely. So right now, I will also preface this with, there are a lot of research aspects and a lot of consultants that are part of the pilot project. And so the costs right now, I mean, per unit, we are, we're pretty much around almost the 200,000 mark, depending on where you'd want to draw that line. Overall, the overall budget is about $750,000, so $750,000 for these units. When we start to chip away some of the things that you probably wouldn't be doing again, just because this is the pilot, and you want to make sure that you've got that monitoring, that you've got this extra consulting, but really, once you get rolling, you probably would avoid certain costs. Right off the bat, we're hoping that we're going to be able to chop off maybe close to a quarter of that, and then hopefully we're getting ourselves somewhere. In all honesty, the target is somewhere around $60,000 to $80,000 is where we're targeting from the business case point of view, if you will. Like, I know that we're going to be, the net present value of what we're spending on these units for the next 30 years is somewhere, and including the energy, is somewhere around $60,000 to $80,000. So if we can get it within that range, that's kind of the target, and that would represent something like a third to half of a drop. And maybe Mark can kind of speak to what they've seen in the Netherlands from their scaling.
Yeah, that's.
Oh, sorry.
Yeah, sure. No, very quickly, I think the initial projects that we're aware of, at least in the Netherlands, cost around 120,000 euros per unit for this kind of similar typology. So not frankly that different than the costs that OCH is incurring, but they've managed to compress that down by about 50% so far. They've done 5,000 of these units. Their goal is to get it down to about 40,000 to 50,000 euros. So about the same, I think, when you convert to where OCH wants to be. And that for them is they can sell these then based on the avoided energy costs alone, and then anything else on top of that is just gravy.
Our cheaper energy cost means that ours is a little bit longer, but essentially the same thing. If we can get around 60 to 80, we will be spending that in the next 30 years. So we're just paying it up front and covering our cost. And then if it lasts 40 or 50 or 60 years, then we're ahead of the game. We're saving money.
Jim, did you want to ask your question while we're still talking about costs, or?
I just wondered whether you wanted to comment on the life cycle costing of A versus D. You knew I would come up with that, didn't you?
Absolutely. So how about this? We've got Jim Nosted from CFAR here in the chat, and we're me and Mark and Jim are working with the Sundance project as well to kind of do an evaluation of a total cost of building ownership, which is really the way, because we're talking about more than just energy savings now. We're really looking at the life cycle of the building and trying to incorporate all of the costs to make that business case. And so the work that we're doing with Jim is trying to show that. And right now, I mean, just round numbers, over the life cycle of 60 years, we're hoping that we'd be saving about $1 million on these 4 units. So when you talk about that, then you start, now it really gets to the conversation of real affordability. There's a cost to not doing it at that point. And we're actually improving the affordability of our overall building stock and potentially saving money to make new stock by taking these actions. But it does require a little bit of shift in the way that we're thinking about it. And we're working diligently with CFAR so that the financing side of the corporation will start to look at these types of retrofits in that light.
All right, final question before we close it off, unless somebody has something pressing, but would this system be appropriate on small commercial and multifamily apartment buildings?
Absolutely. Like definitely, I mean, what we're looking at right now is, we'll call it low rise, but really like these same panels, I would see no reason why you couldn't at least go up 3 or 4 stories. When you start to get higher and higher, then you've got also a different construction. You might end up with a different panel. And maybe Mark, maybe in your commercial discussions, I think you have had discussions with some of that industry.
Yeah, that's where we want to go next for sure. To your point, David, I think it's probably even more appropriate in a lot of small commercial or multifamily buildings. There are different code requirements, obviously, once we start getting into part 3 buildings, and fire separation and fire resistance. But that's where we want to go next with the sort of the R&D side of things. So yeah, very much so. In fact, I'll just make a little plug before we get off the phone today. If there's anybody, we're trying to reach out to both building owners and to the industry, like the supply side. We have an industry working group. If there's anyone on the call today who'd be interested in participating in that, please reach out. I'd love to hear from you.
Mm-hmm. And just a little quick note, so OCH is also looking at its high rises in this same light, and we actually have a pilot going on. Well, the first building that we are trying to do some sort of re-skinning on a 15-story high rise at 1485 Caldwell. This is it was spawned from a structural issue. So the initial reason for the retrofit was actually structural, but we took the opportunity to start testing out some membranes on the side of the building and adding some of that insulation. So not a whole lot, and by no means targeting any sort of net zero. But we're starting to think about that, and those 100 high rises that I talked about, we've got to bring them to net zero just as much. So they are also they're next on the chopping block.
All right. Can I just say that I loved how everyone's face lit up when a child came on screen. So that was really heartwarming. So thank you. There's no other questions in the chat. We're at our hour. So I just want to say thank you. Thank you so much to Dan and Mark, but also thank you to everybody who joined us here on the call. Thank you to Ducks and Windows for helps making this possible. But like, seriously, it's really inspiring to see all of you folks thinking about all these things, all of the research that's going into things. And I'm looking forward to future conversations on how to like make more of this happen here in Manitoba. And I think there's not a single person on this call who can't be part of that discussion. So, all right. So we'll see you next week for our last tour. We're going back to Churchill to see how they grow fresh greens up there. So have a great week. And thanks again, everybody.
Take care. Bye.
Thanks very much.